सो वेलकम बैक गाइस टू फिजिक्स मेड सिंपल। आज की वीडियो के अंदर वील सॉल्व अ वेरी अमेजिंग ब्रेन टीजर which I gave in the last video. आपके सामने क्वेश्चन है। Four particles A, B, C and D are initially at four corners of a square of side A. Each particle moves with a uniform speed v in such a way that A moves directly towards B, B moves towards C, C towards D, and D directly towards A. At what time will these particles meet each other? What is the total distance covered by each particle? And what is the angular velocity of the particles? What is the distance covered by particle A when it completes one revolution around the center of the square? So, this is the question, and this is the diagram. As you can see, there are four particles at the edges of the square A, B, C, D. What the particles are doing are they're trying to approach each other. And you have studied in class 10 that when a particle in a system accelerates, it radiates its energy and ends up at the center of the nucleus. So that is what is happening with these particles in the square. The particle is accelerating, radiating energy, and ending up at the center. Say, oh, B also is radiating, accelerating energy, and ending up at the center of the square, as for C and for D. Also, we have also studied another concept that what is velocity? Velocity is the tangent to direction of motion of a particle. So, of course, here the tangent to A is velocity, the tangent to B is its velocity towards C. Let's go on with the solutions. Of course, one more thing to note. The side of the square here is A, small a. Okay, so the particles are radiating energy and ending up at the center of the square. In the first question, they asked about the time. Let me recheck. Yes. At what time will these particles meet each other? How much time they take to reach at the center of the square? So we know that time equals to distance upon speed. Okay, so the speed here is, as for the speed, we can do one thing. I'll take a ruler to make it clean and tidy. So as you can see, the component of velocity towards this angle makes 45 degree, and the component of velocity v of particle B towards the center O, what's it? Towards the center O is v cos 45. That means v upon root 2. That means v upon root 2. As for the distance, it is a upon root 2. When we solve, we'll get the distance as a upon root 2. Of course, so when you put it in the formula, a upon root 2 upon v upon root 2 gives us a upon v. So the time is a upon v. Now we have one more conceptual thing to know. I told you guys this, but there is also one another thing to note. You should understand the animation of this. Like, it's the velocity of particle v at t equals to 0 when it has just started. Say, for example, out here, the particle v is here. Its velocity would be, of course, tangent to direction of motion, here like this. Also, it would be same for C, for D, and also for A. Now, when you join these dots, like say at time t, if I want to change the color, let's make it green. At time t, they are all out here, here, and here. It's not proper, but you guys can visualize. Yes. So again, it is a square. So what is happening is the square is rotating, and it is even the square is rotating and decreasing in size. I can make the diagram here. You'll get a feel of it. Like say at the initial state, it is like this. Then it becomes like this. Then it becomes like this. Then it becomes like this. Then like this. And so on and spiral into the nucleus. So what is happening is the square is rotating and decreasing in size. So this was V upon root 2. I guess you guys got the concept, the visualization. Let's move on to the second question. What is the total distance covered by each particle? So that's quite simple. We know distance equals to speed into time. Our speed is v. Time we have calculated is a upon v. So the distance is a. Now, we know that the side of the square is a. So that's the beauty of physics and mathematics, that it is naturally maintaining symmetricity. Even though the direction of motion of the particle is semicircular, its distance covered is a only, same as the side of the square. What is the angular velocity of the particles? Now they are asking the angular velocity. Okay, I can tell the angular velocity by two methods. First, okay, say the note one thing, that the direction of motion of velocity of c is perpendicular to direction of velocity of b relative to b. The velocity of b is along c and it is perpendicular to c. the velocity of c is perpendicular to b. So here omega, we know that omega is relative velocity of b. We are calculating omega, है ना? The rotating speed, omega is also known as the rotating speed. Relative velocity of b upon this. The length bc as a function of time t. Relative velocity of b as a function of time t we are taking upon bc as a function of time t. So omega relative velocity out here is b. We know that t equals to 0, bc equals to a minus at time t, it's v into t. So as a function of time it would be a minus vt. Omega equals to v upon a minus vt. That's the answer. So okay, look at other method. We look at other method. Say, take a component of the velocity vector v perpendicular to OB, which is again 45 degree. So it would be v upon root 2 again. We are calculating omega, the rotating speed. Oh, it's from the center. So omega is relative velocity of v upon bc. We know that omega equals to our relative velocity of OB upon the length of OB. So the relative velocity out here is v upon root 2 upon OB. Here we are calculating OB as a function of time t. Just a second. V upon root 2 upon OB. Yes. OB is a function of time t. That means yes. What is the initial length? For OB the initial length is a upon root 2. Here the length of OB is reducing as a function of time t. As a function of time t. So it would be a upon root 2 minus speed into time, है ना? V upon root 2 into t. Putting the values V upon root 2 upon 1 upon root 2 into a minus vt. This would give us omega equals to v upon a minus vt. So the last question asks us, what is the distance covered by particle A when it completes one revolution around the center of the sphere? Now that's an interesting question. The distance covered by particle A, okay, we are taking A. The distance covered by particle A when it completes one complete revolution, like around the center of the square. Something like this it would be. The motion would be something like this. And again reaching out here. So they are asking about that distance. So they are asking the distance covered by a particle A to complete one revolution around the center of the square. We know that omega equals to d theta upon dt. Let theta be the angle rotated by the square. Theta be the angle rotated by the square. So let's take it like this. D theta equals to omega dt. Omega we have calculated. D theta equals to omega dt. We know that omega is v upon a minus vt dt. Let's integrate it. Let's integrate it from 0 to 2 pi and the time dt 0 to 2t. So it would be upper limit minus low 2 pi minus 0. For air it would be natural logarithm a upon v will take out. It would be natural logarithm of a minus vt upon minus v, the coefficient of t, into a. We can also write it as logarithm of a upon a minus vt. Taking e की पावर both side, e की पावर 2 पाई यहाँ पे कर लेते हैं एंड वो log base ही होता है तो वो सब हट जाएगा and it would be left with e की power 2 pi equals to a upon e की power 2 pi equals to a upon a minus vt. A minus vt equals to a into e की power minus 2 pi. And further solving it would be t equals to a upon v into 1 minus e की power minus 2 pi. So this is the time taken by a particle to complete one revolution around the center of square. They are asking us the distance covered. Distance हमें पता है speed into time होता है multiplied by speed. So into v करके यहाँ पे हो जाएगा आपका distance equals to a into 1 minus e की power minus 2 pi. So that's the answer. That's it. Distance equals to a into 1 minus e की power minus 2 pi. So that's it for this video guys. मैंने आपको सारा कॉन्सेप्ट एक्सप्लेन कर दिया, सारे क्वेश्चंस एक्सप्लेन कर दिए. I hope you like the videos guys. See you in the next video.